In this video, we're going to discuss a few questions on chromatography, which is usually found in the paper 2 of IGCSE Chemistry. Now look at this question. Two different food colorings X and Y are tested using chromatography. It's here. Three pure dyes are also tested. So which statements are correct? X and Y both contain 2 or more dyes. X contains 3, Y contains 2. So that statement is correct. Dyes 2 and 3 are present in both X and Y. Dye 2 is this one, which contains in both X and Y. Dye 3 is also in X and Y. So that statement is also correct. The RF value of dye 1 is 0.625. How do you calculate the RF value? RF value is the distance traveled by the solute over the distance traveled by the solvent, right? So you look at the distance traveled by the solute in dye 1, which is, let's take it as 5, right, over distance traveled by the solvent is the distance between baseline and solvent front, which is 8, and that comes down to 0.625. That's also correct. So the right answer is C. Look at the next question. Which statement about paper chromatography is correct? A solvent is needed to dissolve the paper, which is wrong. We don't dissolve the paper. We need the paper as chromatogram. B, paper chromatography separates mixtures of solvents. It doesn't. It separates the mixtures in the sample, which is the solute. The solvent should cover the baseline. It should not. What if the solvent covers the baseline? The spot, the sample, may dissolve in that solvent and go all over the solvent. It might not go up and get separated. The baseline should be drawn in pencil, and that's the correct answer. The baseline should be drawn in pencil. That's correct. The chromatogram from 4 different substances is shown. Which pure substance has the largest RF value? So the one common mistake people usually make is just look at the chromatogram and pick the one that has traveled the highest distance. But here there is a clause. It has to be the pure substance. So let's rule out the substances that are not pure. Look at this one. This has 2 dots, so that's not pure. And B has 2 dots or 2 spots. That's also not pure. So we have got 2 pure substances, which is A and C. So if you compare A and C, clearly C has traveled a longer distance, so which has the largest RF value. A mixture of colorless compounds is separated using chromatography. Which type of reagent is used to detect these compounds after separation? So the keyword is colorless compounds. So when you have colorless compounds, that is under chromatography, we always need to use a locating agent, right? So when you need to get colorless compounds separated, you would need a locating agent. How else would you see that on a paper, right? Great. Now, paper chromatography is used to determine the RF values of 4 different food colorings. Which food coloring has an RF value of 0.6? It's just math. You just have to calculate for each of them. So 10 over 25 is 0.4. We need 0.6, so not A. 20 over 25 is 0.8, not this. Now 15 over 25 is actually 0.6. So this is the answer. The chromatogram of substance S is shown. Some distances are labeled on the diagram. How is the RF value of the substance S calculated? Again, the same question. It's the distance traveled by the solute. So let's look at the distance traveled by the solute, which is for this particular substance S, right? So that should be Y. So Y should be on the numerator, and the distance traveled by the solvent is the distance between baseline and solvent front, which is X. So we have only one option here. So the answer should be C. Chromatogram for an unknown dye is shown, right? It has traveled a distance of 9 cm, and you could see that the distance traveled by the solvent is always the distance between the baseline and the solvent front, which is 12. So the RF value of that particular dye should be 9 over 12, which is 3 over 4, 0.75. In the chromatography experiment shown, which label represents the solvent front? That has to be this. This is a spot, this is the solvent, and this one is the baseline. Alright. RF values are used to identify unknown substances using paper chromatography. Which statements about RF values are correct? RF values are always less than 1, which is correct because it's always something, the denominator is always larger than the numerator. So you will always get a value which is less than 1. That's correct. RF values is equal to the distance traveled by the solvent over distance traveled by the unknown substance. It's the other way around, so that's wrong. The higher the RF value, the further the unknown substance travels. That is correct. RF values are not affected by the solubility of the unknown substances. That is wrong. It actually does affect by the solubility of the substance, because higher the solubility, larger the distance it travels, right? So that's wrong. So 1 and 3 is B. A colored dye is separated by chromatography. One component of the dye moves a distance of 13 centimeter and has an RF value of 0.86. Which distance did the solvent front move? So that is 0.86 is equal to 13 centimeter over, let's say the solvent has traveled X. So X is equal to 13 over 0.86, and which is 15.1. The chromatogram obtained using 4 substances is shown. Which statement about M is correct? So we are talking about M. It is a mixture of J and K only. No, it cannot be because it has a third component. It is a pure substance. It cannot be because you see more than 1 spots. It is a mixture of J, K and L. No, clearly not, because you don't have something associated with L here, so it cannot be that one. So that's also wrong. It is a mixture of J, K. That's correct. It has J, it has K, and an unknown substance, which is actually correct.